All right, today we're going to be talking titrations. So what is a titration? A titration is an experimental technique used to determine the concentration of an unknown solution. The process of a titration is that a solution with known concentration, which is our titrant, is added to a particular volume of the unknown solution, which we call the analyte. A reaction occurs between the two species, and the amount of titrant necessary to reach the endpoint of this reaction is recorded. Calculations are then done to determine the concentration of the analyte, which you can use to find the volume or the mass of the analyte. Some techniques and uses. There's multiple types of titrations that are done by chemists and other scientists, such as the oxidation reduction titrations, which are redox reactions, acid-base titrations, where you use a strong or weak acid to neutralize a base, and conductometric titrations, which we can see in the diagram over here, which is where you have two electrolytes that as your solutions, and you monitor the conductivity of the solution as the titrant is added. Titrations are used across many fields and industries to determine the amount of a particular chemical in substances such as blood, rainwater, food, makeup, and pharmaceuticals. So these are widely used techniques in laboratories all over the country and world. A deeper look at how the titration works. So we can see our setup here. We have a flask with our analyte, which is the unknown solution, and we know the volume of this. We have an indicator, in this case, in a stoichiometric titration, which will turn pink once the reaction goes to completion. On our stand, we have a burette, which is filled with the titrant, of which we know the concentration. And as we add that titrant to the flask, in a acid-base titration, as we add the volume of our base, NaOH here, which would be our titrant, the pH would begin to slowly increase as the reaction takes place, and it neutralizes some of the acid that is our analyte. And we'd reach the equivalence point at a pH of 7 once the reaction is completed and the solution is completely neutralized. And then we would record how much of the titrant we actually needed to use, and that way we could determine how many moles of the analyte was in that volume of analyte. Some tips and tricks for making good titration experiments. Ensure the burette has been washed out before using it. So this means to use the titrant and wash it through the burette a few times to ensure that no water or other substances are in the burette that would skew your results. Use a rough trial first to narrow in on the equivalence point. This way you'll know when you should start seeing the reaction come to completion. And then use a stir rod to ensure the reaction happens as quickly as possible and that you're not waiting for the reaction to happen. You might miss the endpoint because you added too much titrant. Slowly add the titrant when nearing the equivalence point. This way you won't go over and you can get as accurate as results as possible. And use multiple trials to ensure precision and to get the best data possible. For your references, thanks for watching.